Okay, so we said that we have these different data types, and some that we've seen already are integer and double, and maybe we saw object a little bit and string, but there are other data types as well. Now, why do we have data types? Basically, we just have data types because once you say that something is an integer, then the computer or the compiler knows how to efficiently handle that. So it makes use of the fact that it's of a certain type. So it's just a kind of convenience. You could never bother to define anything as an integer versus a double versus something else. You could just declare them as objects. But that would be inefficient. It would use a lot of memory, lots of memory, when maybe all you needed was, like, remember we just talked about bits and bytes. You might only need 1 byte, for example, to express something. But if you declare it as an object, the computer, remember we said that these bytes are basically, I said that we have many billions and billions of switches, and each bit tells one of those switches to be on or off. So if we only need 1 byte, eight of these bits, we only need, say, 8 of those switches. But if we declare, even though we may only need 1 byte, if we declare it to be an object, it might the compiler might reserve, or the computer might reserve, like 50 bits. I'm sorry, 50 bytes of memory, even though we only needed like 1 byte, or I'm sorry, yeah, 1 byte. So it would be a big waste of memory. Now, for programs that we're writing, it's not going to make any difference because we're not using much memory anyway. And also the other thing is that computers have a lot of memory now anyway. But I'm sure you've seen sometimes when your computer starts to run slowly because you have too many programs that are open at the same time. Maybe you haven't seen it, but it does happen. And that's because you're using too much memory. So there are cases where we end up using too much memory. So as a programmer, you don't want to use more memory than you need to. So in that case, you'd like, if something only needs to be an integer, then don't call it an object, or don't even call it a double. Okay? So anyway, that's just an introduction. But so we have a byte, which we said is 8 bits. And so we can ask, how many numbers can we express using just 1 byte of memory? So if we go back to here, if we use just 1 byte, that means eight of those switches that I was talking about. So if we use just 8 switches, so we can say whether each switch is 0 or 1, and we have 8 of them. So we can have, this could be 0, 1, 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 this could be 0, 1. It could all be 0, 1. So how many different sequences of zeros and ones can we write in that case when we have 8 of these spaces, or 8 bits, or 8 digits, 801 digits? How many different sequences can we write? Well, if we just to think about it quickly, if we only had 1 bit, just 1 space, we could put a 0 or 1, so we could write 2 different numbers that way. If we have 2 spaces, or 2 bits, then this could be 0, 0, this could be 0, 1, this could be 1, and this could be 0, or they could both be 1. So that's 4 different possibilities. If we had 3 bits, or 3 switches, or 3 spaces here, we could have 0, 0, 0, could have 0, 0, 1, could have 0, 1, 0. So you can figure out all the different possibilities. There will be 8. So it's 2 possibilities, 4 possibilities, 8 possibilities, 16 possibilities, 32 possibilities. Next, 64, no, yeah, 64 possibilities, something's wrong. Anyway, actually there are 256 different possible numbers we can express with 1 byte of memory. In other words, 256 different integers that we can express. So we say we can express from 0 to 255. Okay, let's stop here and continue with this slide.